Okay, so if you look at a wave and if you see the amplitude decreasing, so we'll just make up numbers here. If the amplitude starts as, let's say, 1 centimeter, and then it decreases to 0.5 centimeters, without looking at the textbook, I know you've read it already, but without looking at the textbook and without thinking about what you've read already, what do you think would happen to the intensity of the wave? Just basically tell me what's the relationship between the 1 and the 0.5, and what assumption would you make about the intensity? So if I called this the first intensity, and if I call this the second intensity, what assumption would you make about the intensity?
That it halved?
Correct. So the assumption is that you would halve it. So the assumption would be that if we halve the amplitude, we would halve the intensity. But it turns out that that's not the case. It turns out that the amplitude is proportional to the intensity is proportional to the amplitude squared. So if you look in the textbook, what they say is that the intensity of a wave is proportional to the square of the amplitude. So I'll give you a quick example that'll make sense. If you take just a small wave and then you sort of double its amplitude. So let's start with 1 and we go up to 2. If that one gets times by 2, just based on square proportionality, if you think of k factor, k squared factor and everything, just based on that, what would you say happens to the intensity?
Wait, so are you drawing something or?
Yes, can you not see it?
It's just white, like the screen is white. No,
Completely
can't
white.
see
It just says wave energy. It just says wave energy page
It just says
227.
Oh, then it's not scrolling. Sorry, I am drawing. It's obviously lagging. It's taking a time to get through. Okay. So I don't know if it's the tablet or the internet or both, but it is sharing the screen on my side. I can see it moving. So you don't see anything at all.
We just see wave energy page 227.
Interesting. Okay, let me stop share and reshare.
Same.
I'll stop share, reshare. Let's see if that helps. Technology is not our friend today. Technology is not doing us very well. Well, if that doesn't work, then I'll just try and use the touchpad. I'll just use the computer screen. Cool. Do you see anything now?
Yes.
Do you see the I
Yes.
is proportional to A squared? Okay,
Yeah.
excellent. There we go. That's better now. Okay, so if I take intensity 1, sorry, let me just be more specific here. The amplitude here is measured as 1 centimeter and the amplitude measured there is 1 centimeter. And then based on the proportionality, if I tell you that is proportional to square of the amplitude, if I double the amplitude, what happens to the intensity? So think about when you change the length of a triangle and then you work out its area. If I double the length of one side of a triangle, what do I do to the area of the triangle? Cool. Anybody?
Decreasing?
No, what I'm saying is, so think back to maths when you did proportionality. If you think about a length is a one-dimensional quantity, an area is a two-dimensional quantity. If I double all the lengths in a triangle, do I double the area or do I increase the area by more than double? More than double, correct. And because it's proportional to the square, this one here will become 2 squared. In other words, times by 4. So in other words, whatever the original intensity is, the second intensity will be 4 times, sorry, let's undo that. Undo that. Intensity 2 is equal to 4 times intensity 1. Cool. Do you want to do an example with the triangle just to make sure you understand?
Sure.
Cool. Let's do an example of the triangle. So example with a triangle. Cool. So we're going to draw two triangles. No particular lengths. So no given lengths. We're just going to draw it. And all we're going to do is we're going to scale up that triangle exactly to all the double lengths. So if we call this L, we're going to just call this 2 times L. But what do you remember about the area of the triangle? If I call this area 1, and if I call this area 2, what happens to the area when I double the lengths? Anybody? Cool. So what's the K factor? If I look at just the lengths, what is the K factor going from L1 to L2? What have I multiplied by the lengths? What is the K factor?
Multiplied by 2.
It's 2, correct. K is equal to 2. I've doubled the length. So in other words, the scale factor is 2. And then what factor do we use when we look at the area? Do we use the K factor or do we have to use a different K factor?
K squared.
K squared, correct. So we use K squared, which is equal to 2 squared, which means that K squared is equal to 4. So what can you tell me about the area of the triangle on the right-hand side compared to the area of the triangle on the left-hand side?
The one is the square and the other is the square root.
Just in terms of scale, by how much is A2 bigger than A4?
2 times.
Not 2, because the area is not K factor. The area is K squared factor.
It's 2 squared.
2 squared, correct. So it's 2 squared times A1, which means that it's 4 times A1. Cool. So basically what we're saying is that if I, let's highlight this here. If I double the length, I square the area. Does that make sense? Sorry, when I double the length, I multiply the area by 4, by 2 squared.
Sir,
Yes,
if you multiplied the lengths by say 3, then
Correct.
the K factor will be 3 squared.
correct. So let's do that as a second example. So let's do exactly the same scenario, but let's just multiply it by 3. So take the same triangle, start with length L, start to 3L, and then ask yourself, what is the K factor? By how much did you increase the length? Increased by?
3.
3, correct. Which means that if I look at the area, if I take area 1 and I call this one area 2, by how much did I increase the area?
3 squared.
Correct. So K squared is equal to 3 squared is equal to 9. So it means that if I wrote a relationship, A2 is going to be equal to 3 squared A1, which means that A2 is equal to 9 times A1. Cool. So that's basically what we're saying. And if we go back to the original, the thing with the waves, it's exactly the same concept, except that now it's that if I multiply the area, the amplitude, sorry, now in this case, A is amplitude. If I multiply the amplitude by 2, I multiply the intensity by 2 squared. So the relationship that we're looking at here is that the intensity is proportional to the amplitude squared.
So intensity is something to do with area.
Correct. You'll see when you read the book. We don't have to talk about it in terms of power over cross-sectional area and whatnot. The triangle was just an example to show you how when things are square proportional, doubling something doesn't double that other quantity. It scales it up by a factor of that quantity squared. Cool. So let's do another example with a wave, just a simple wave example. And then what we'll do is we'll start using ugly numbers meaning numbers that are not directly whole numbers, 2s and 3s, etc. So let's do a quick, simple whole number example. So if you have a wave, let's just make up a number here. Give me a value for the first amplitude, any value that's a nice whole number.
2.
2, cool. So that's 2 centimeters, the amplitude. And then give me a number that's a multiple of 2, and you can multiply it by anything you want. So multiply 6, there you go. So 6 centimeters. Here we go. So that's a nice one. And then you're gonna ask yourself, what is the K factor? By how much did you increase K the amplitude? So A is times by how much?
3.
3, correct. So now when we look at the intensity of the wave, so if we look at I1 compared to I2, if this is I1 and if this is I2, by how much does the intensity increase? The intensity increases by 3.
Squared.
Squared, correct.
so it's
Intensity is times by 3 squared, correct. So in other words, I2 is equal to 3 squared I1, which is equal to 9 I1. In other words, if I increase the amplitude by 3, I increase the intensity by 9. Oh, everyone happy there?
Yep.
Good, good, good. Okay, so now we're going to use what I call ugly examples. When I say ugly examples, I mean we're not going to get nice whole numbers. We're going to have to use a bit of maths to work out values. Also, I'm going to call this one, and I'm going to call it inverted commas, ugly numbers. I always like to say ugly numbers because they're not whole numbers. They're not ugly because they're not beautiful. So they're just not perfectly nice numbers. Okay, so start again with the wave, increase its intensity. And then we're going to start. Now what I want you to do is just give me 2 random numbers. Don't worry about multiplying them by anything. So what do you want on the left-hand side?
3.
3, cool. And then what do you want on the right-hand side? Any number that's not even a multiple. Don't even worry about trying to multiply it by anything. Just give me a number.
15 over 6.
Not a fraction, just a whole number, but something that's not a multiple of 3.
19.
19, good stuff. Okay, so 19 isn't a perfect multiple of that. Okay, so now you don't know the K factor. The K factor is not that obvious, but how do you work out the K factor? So what do you have to say to work out the K factor? Ooh, by what
19.
proportion? 19 divided by?
3.
Correct, so the
3.
K is 19 over 3. In other words, if I took the 3 and I multiplied it by 19 over 3, that's going to give me 19. So I had to multiply 3 by 19 over 3 to get to 19. Cool, so that's my K factor. So that is my K factor over there. Okay, then you can say, what is your K squared factor? So now you can ask yourself, well, if K is 19 over 3, what is K squared?
19 over 3 squared.
Correct, 19 over 3, and that's squared. Cool. So that means that I can calculate the intensity 2, and intensity 2 is equal to what in terms of intensity 1? Oopsie, excuse me. So who has a calculator with them? I've got one with me, but who's got one with them? Quickly, they can check with me.
Um, 40.1.
Correct, so it's 40.1. So you can check that on a calculator if you multiply 19 divided by 3 times 2. So 19 divided by 3 times 2. Okay, so that's how you can do it just using K and K squared sort of factors or whatever. But what you can do is you can kind of summarize the equation. I'm not going to show you the maths of how to derive the equation, but I'm just going to show you the sort of summary that you can use. When I say can use, I mean you should use. So I'm going to call this a summary equation. Oh, now the tablet's lagging again. That's fine. We've got like 5 minutes left, then we'll end the meeting. Summary. Oy, 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 oy. Technology not good today. Let's see if we can close the app and start it again. Oh. Sorry guys, give me a second. It's not working well. Let's see now if it works. There we go. Summary equation. Cool. And this is based off what you can read in the textbook, and it's based off just a bit of mathematical rearrangement of the formula. So what we can say is that the intensity, the ratio of the intensities is equal to the ratios of the amplitudes squared. Cool. So that's squared. In other words, if I'm given any three of those quantities, I can calculate the third, or I can calculate things as a ratio. So would you agree with me that both sides are just ratios? So that's the ratios of intensities, ratios of I, and this is just ratios of A squared. You can figure out how to work that out mathematically. There's a little thing in the textbook that'll tell you about it in terms of intensity of amplitude squared as a constant. And we're basically saying that you can rearrange it to form this equation. And then once you have this equation, you can literally just plug in the values and you can work out whatever you want. Cool. So this is the important equation. This is the sort of summary. This is what you should add to your notes as a skeleton equation. Cool. So you add that to your notes. And whenever you see an intensity and amplitude problem, you plug in the values into this equation here. Cool. So let's do one example. And in this case, I'm going to tell you the change in the amplitude, and you're going to tell me the change in the, I'm going to tell you the change in the intensity, and you're going to tell me the change in the amplitude. So we're going to start with this. Let's draw a small wave, draw that wave. And now bear in mind what I'm telling you is I'm telling you the intensity of the two waves. So I'm not telling you the amplitudes, I'm telling you the intensities. So this here starts with, let's say, 2 centimeters, and it starts with intensity 1. We don't know what the intensity is. We're just saying it starts with some certain intensity. And then what it does is we increase the intensity to, let's call it 10 times I1. So intensity 2, sorry, I'm going to use a different color. The green doesn't show up well on the videos, I realized. So the first intensity is I1, and the second intensity, I2, is equal to 10 I1. In other words, I've increased the intensity by 10. By 10. And then the question will ask you something like this. The question will ask you, what is the amplitude on this side? Now, does it seem simple at first until you think about it? What I mean to say is, well, if I've increased the intensity by 10, then surely I've increased the amplitude by 10. Is that what you're kind of thinking?
No.
Well, you shouldn't be, correct, because now you know that it's not the case. In other words, it's just because I've increased the intensity by 10, it doesn't mean I've increased the amplitude by 10. So now you've kind of got to work backwards and say, well, I have the k squared factor. What is the k factor? So if k squared is 10 over 1, then the k factor is square root of 10 over 1. But instead of having to do all that sort of logic, just plug it into the equation. So just plug it into the equation. So we're going to use this equation and we're going to solve the question. So we're going to say I1 over I2 is equal to I1 squared over A2 squared. So let's see if we can do that together. There we go. So start with the equation. I1 over I2 is equal to amplitude 1 squared over amplitude 2 squared. Okay, I'm going to start on this side here on the left-hand side. What can we summarize? What can we replace I2 with? What can we replace I2 with?
Isn't it 20 because it's 10 times?
No, sorry, what I mean to
I1
say,
is
correct,
10.
I1, correct, 10 I1. So let's see if I can do this. I can say that this is equal to I1 over 10 I1. And would you agree with me that the I1s would just cancel and I get left with a ratio of 1 over 10? Correct?
Yes.
Yes. Okay, and then we can say, what is the amplitude 1? Amplitude 1 is 2, and I want to square that value. And I want to solve for A2, which is also squared. Oh, and would you agree with me that if the i's cancel, I'm basically left with only, two numbers, and a squared is the only variable. Correct?
Yes,
Okay,
sir.
good. So now we can take it one step further and we can write that as an equation. We can say 1 over 10 is equal to 2 squared over A2 squared. And then we're going to solve for A2. So solve for A2. Okay, so take the A2 across. So we'll have A2 squared over 10 is equal to 2 squared. So I've just moved the A2 across, and then I can multiply both sides by 10. So I can say A2 squared is equal to 2 squared times 10. And then I can do one more. A2 is equal to 4 times 10 is 40. So it's square root of 40, which is 2 root 10 or 6.32. And that's centimeters, 6.32 centimeters. Cool. So it's 6.32 centimeters. And what does that all mean in the bigger picture? What that means in the bigger picture is if I go back to my graph, I can now replace A2 with A2 is equal to 6.32 centimeters. Cool. Could you have done it a different way? Could you have done it using k squared and k factor?
Probably.
Probably, yes. So I'll give you a 10-minute break. When I say 10 minutes, I mean don't log on until 10 to 9 again. And all I want you to do is just quickly look at this problem. So look at that problem over there and see if you can use it just solving ratios and squaring and factors and things without plugging into the sort of summary equation. So see if you can solve it a different way. See if you can try to solve it without using the summary equation. And then what you've got to do is convince yourself that you've actually done the same thing in a different sequence of steps. Cool. So I'll give you 10 to 15, let's say 15 minutes. That's a good time period, 15 minutes. And I want you to see if you can solve this using a different method.
Still this question.
Still same question, 100%, and see if you can solve it using a different method. When I say different method, you'll see once you start the process, you'll realize that you're actually doing the same thing in a different order. Cool. So give that a try, see if you can do it.
Log in.
And log in at 5 to 9.